Today, okay, so what we're gonna do today, I think we're gonna do a couple of things. So there's gonna be at the end of today's class, there's gonna be a form that you guys gotta complete. I think the form is just like just some general feedback. Um, because I think your guys' grades are gonna be hopefully released soon. I think around what is it? December was we're the 9th right today, so your the final grade for you guys will be released I think around after Christmas, or you guys will definitely know your grade around Christmas. Um and then yeah, so and then the other part of the form will just be like general feedback on how this semester went. And then if you guys have any questions or comments, and just include it in the Google form. It'll just be marked for completeness. So if you guys complete it, then it's considered attendance and whatnot. So right. So for today's class, what we're gonna do, so can everyone see my screen? Give a thumbs up in the chat. Okay, great. Okay, so today's lab, I'll go review it, but essentially you guys will have, it's a take-home lab, so you're gonna need to complete basically this. It's I did it, so it didn't take me long at all. It's probably, I don't know, I think a good hour. And then it just shouldn't take too long, but let's review it. So the materials you guys will need is a bag of marshmallows. I think it's like less than $2 in Walmart or dollar store or wherever, and then a ruler. So what you want to do with the marshmallows is essentially make it like almost like you're making a s'more, but so you have to melt the marshmallows. So the procedure is already written out here, so you guys don't have to do that. But we'll go over it. So it says place the sheet of parchment paper on the bottom of the dish to facilitate cleanup. Okay, don't need to worry about that. Okay, when finished measuring, place some of the chocolate cake. Okay, so then you want to, second step, place a single layer of marshmallows on the bottom of the dish, packing them close together. Cook on low heat, where you're basically melting it. Observe the melted spots, so look for the smallest distance between them. What I saw in my observation was 6 centimeters, but if you're within like, I don't know, like 5, I even accept 4 centimeters should be good, but anything less than 4, then just try and like make it so that it's like around 6. So okay, so part C to get okay, so what we're looking for is frequency and lambda. So basically if you have, I think 6 centimeters apart would be 3 for the lambda, but in this case I got 12. So okay, so right. So once you do that, you're gonna have to take, so I want essentially when you guys submit it, what you'll do is on a fresh document, you'll copy and paste all of this stuff first. And then add it to your file. Then after that, like for the observations, you should just take a photo. don't worry about like drawing the lines if you can't do so, but you can just it's just pretty straightforward. Like when you take the photo, like you'll be able to see the distance between like these melted spots, and the melted spots are completely like melted. Like it's not the middle part should be that. Now, okay, so here's the main chunk of the lab where you guys will have to do all of your work. So the purpose of this lab is to determine the speed of light using a microwave. So the method, we're basically measuring the hot spots between the marshmallows. So in your observations, you're gonna, in my case, it was 0.6 meters. Remember, you got to convert it to standard notation. Okay, and then actual microwave wavelength, we'll get about, in this case, you can just use the convention 2,450 megahertz. That's fine. Oh, 2,000 megahertz, and then calculate C using the universal wave equation, including uncertainties. So actual microwave wavelength would be 12. So 0.12. Okay. So the calculation part, I'll just write the formula here. So universal wave equation, universal wave equation. What you're looking for is okay. Okay, here. So I'm just gonna take a quick screen capture. Oh, okay. Frequency, wavelength. Okay, so C, so I'll put E here. Okay. So okay. So you're right. So to calculate V using the universal wave equation, we have V is equal to the wavelength times frequency. The question in the chat. Okay, hi Lorraine. Okay, so anyways, so right. So for Lorraine that just joined, basically the lab is posted on Google Classroom, categorized under Lab 5. Essentially what you have to do is you just need a bowl or a dish, like a flat dish, bunch of marshmallows, and then you just microwave them for like 5 minutes. Then measure the melted parts from like the non-melted parts and calculate the distance. And so what you're gonna see is that like all the melted parts are basically where the light has touched, and then the non-melted parts is where light's not touched. So calculating the speed of that light, you're just gonna multiply its frequency by the wavelength. So in this case, we had our frequency to be 2,000 450 times 0.12, and then using my calculator. Okay. Um, of 2,450 times a 0.12, and that should get me 294 meters per second. And I think, what is the speed of light? Okay, so it's 2.9 times 10 to like the 8. I think I did some rounding, but it's around there. So we know the frequency of the wavelength is what's going to be increasing our speed of light in the microwave. So finding the actual microwave wavelength, you'll just have to, once you get the distance between your melted marshmallows and non-melted marshmallows, then I think it will be pretty straightforward. Once you do that, your calculations, then you're just going to go through these questions and say, okay, so your first question is compare your value to the actual speed of light. What you want to do here is just, I guess you can say, calculate the difference. So subtraction. And just show that calculation there. Question 2, microwaves cook by the microscopic frictional effects of water or other polar molecules. How many times per second does the water molecule vibrate? Okay, so um, okay, well, this question is, let's take this one. So let's just go through question 2. That original question 2 is kind of useless because you guys don't have like the tools and whatnot. And I think it just doesn't make too much sense. Okay, let's think question 2. Many people have a misconception that microwave radiation is harmful to food, i.e. nuclear food, making it radioactive or contaminated by altering its nutritional value. Let's assume that ionization of atoms or the breaking of chemical bonds are required to alter its chemical composition. Calculate the wavelength of a photon required to ionize the weakest of atoms, about 5 eV. 1 electron volt, aka EV, is equal to 1.6 times 10 to the negative 19 joules. Hint, use Planck's equation. Okay, this is pretty straightforward. You don't need anything else other than what was given. You don't even need to use the lab. It's just what I'm trying to evaluate in this question is how you guys use Planck's equation. So what region of the electromagnetic spectrum does this correspond to? So the electromagnetic spectrum is this. Okay, so it's just this thing. Let me just copy and paste it to the lab. Actually, okay, 1 second. Okay, yeah, you're probably looking for this one. Okay, so here is what you're gonna need that for what region of the electromagnetic spectrum does this correspond to. So whatever value you compute using Planck's equation, you're just gonna correspond it to this table. In part B, it says calculate the wavelength required to break covalent and ionic bonds, roughly in the 4 to 10 eV range. So what region of the electromagnetic spectrum does this correspond to? So covalent and ionic bond. Um, okay, so sorry, let me just realize we didn't really cover covalent and ionic bonding, but covalent bonding, sharing of electrons, and then ionic bonding is the uh it's still describing the sharing of electrons, but it's when two or more. You're dealing with ions, so uh like sharing electrons between atoms and ionic bond. This is not chemistry, so we're not getting too into it. It's just giving you like the basic understanding of it. So ionic bonding being with ions, and they're basically um held by different charges. Yeah. So um required to break the ionic, and so there, and so I'm just responding to a chat question in the chat. Okay, so back to here. So when you're calculating the wavelength, I think you guys would know Avogadro's number. Um, essentially, um, you still use Planck's equation, so E is equal to hc divided by lambda, and then you basically solve for lambda. So okay, point of that exercise is to see if you can actually solve for lambda. Um, and then again, get the final answer. Just compare it to this graph for the electromagnetic spectrum. When is it due? Karina asked, when is it due? Here, let's just take a vote. Let me just stop sharing for a second. Let's take a vote. So, I don't like to do that. I'm gonna create a, like, like, getting. Can everyone see the notes tab on this one, or, or should be on the side of your screen, I think. Format option. Uh, okay. I don't think. Wait. Okay. I'm trying to create a form. I can. Okay, I guess I'll just put in the chat. Okay, when would be I'm gonna ask you guys this. When would be
What are the options for the student?
what are the options? I would say you have like oh the option. Okay, you got well, 3. Right there. Those are the three options. I guess just right 1, 2. 2 on Wednesday. Okay. Let's see. Okay, that works. Okay, so so Tuesday. Okay, I'll put that in I guess the Google Classroom. Okay, so let's go back to my screen. Uh, Okay, right. So okay, so you're just gonna use Avogadro's number for question. Uh, wavelength required to break the ionic and covalent bonds. Um, Part C, do the same for hydrogen bonds involved in DNA roughly in the 0.15 to 1 eV range. So use the same formula here, solve for lambda, and go from there. But hydrogen bonds have a different H value, and their C value is also different. So now, question 4, you're just gonna do a communication-based question. So you're gonna be, it's like based on our assumptions, do microwaves constitute a significant health risk? This is, there's no right or wrong answer here other than just using your values that you calculated in question 2 and seeing if it's like, so, so the point of this question is like, what's a significant health risk, right? So use that as your, I guess your reference point. And then if your value is way higher than than the recommended health risk, then it is significant. But if your value is low, then it's not a significant health risk. Okay. Question 5, what other factors should be investigated before reaching a definitive conclusion? So what they mean here is basically like, um, I guess question 4 and 5 are the same, but um, yeah, I guess for question 5, I'll just take it out of the assignment because it's the same thing as the conclusion. So in your conclusion, what you just want to do is wrap up, are microwaves harmful to food? And then you can base your answer off yes, because they pose a significant health risk by having a factor of X higher than the reference point, which is health risk, or no, they're not a significant health risk because the factor is significantly lower than the reference point. So all in all, I think this lab should just take you guys an hour. The most difficult would just be getting the marshmallows and the pan. I think everyone has a microwave, so and yeah, so everything is in this document. So you guys are welcome to use the rest of this class to either work on the lab, or if you have any questions, you can ask me in the chat. But that's basically what today's class